All right, in video 3, this is a very familiar AP problem. We're given a piecewise function, and they want us to figure out where specific limit exists. So, k of x is a piecewise defined function above. We can see it, they're defined, where c is a constant. So c is a number, but we don't know what that number is. Can you find the value of c such that the limit of k of x as x approaches 2 exists? How can I find the c value such that the limit of this function k of x as x approaches 2 exists? What do we know? What was the main idea of this section with piecewise functions? If we're given a full limit, I call it a full limit, meaning I'm coming towards x equals 2 from both sides. If I'm given a full limit exists if and only if the limit of the function that we're talking about as x approaches that value from the left, does it equal the limit as x approaches that number from the right of that function that we're talking about? That's the only way it's going to exist. The full limit will only exist if the left side equals the right side. All right. So let's look at the right side first. So when I look at this part for x's that are approaching 2 from the right, that means my x values are bigger than 2. We're talking about this section right here. How do we evaluate? What was the previous pair of videos about? We can evaluate by doing direct substitution. So I'm going to take this function. I'm going to leave a blank there. What is the x value that we're approaching? Well, we're approaching 2. So I'm going to substitute a 2 in there. And then we're going to evaluate it, right? We're going to evaluate what we get when we substitute a 2 into that bottom piece. 2 plus 1 is 3. 3 squared is 9. 9 minus 5 is 4. Let's keep going. What about the left side? I'm approaching 2 from the left, meaning my x values are smaller than 2. Well, that would be this section, because those are x values that are between 0 and 2. So I'm going to take that formula, and wherever I see an x, I'm going to substitute my x value that I'm approaching, which is 2. And I'm going to simplify as much as I can. Well, the only way for me to take this question mark away, and the only way for me to make that limit exist, is to force these two sides to equal each other. And now I've created a little equation there that we can solve. So 7 minus 2c equals 4. How do I solve that? You solve it algebraically, however you'd like. I'm going to come over here. Let's see. Let's subtract the 7 to the other side. I guess we can do that. Minus 7 will give me negative 3. Let's divide both sides by negative 2. And that's going to give me 3 halves, or 1.5. And congratulations, you just found the magical C constant that if I substitute that number into that formula in the orange box, it's going to make the limit exist of k of x as x approaches 2. What that really means is that that's the number that's going to make the middle formula linear graph, excuse me, touch the parabola that's in the third piece. I'm sorry, they're not necessarily going to touch, but they're going to get closer and closer towards the same. They're going in towards the same destination, which is what the limit is. Whether or not they get there, I don't know, but they're heading towards the same place, right? That's what we forced to happen by taking the left-sided limit and the right-sided limit and setting them equal to each other. This type of problem usually comes up in the multiple choice section. So it would behoove us to practice this, and we are definitely going to do that in class.